In today's video, we're going to cover Jellyfin, the free software media system. This is a project that allows you to take files, DRM-free media files like movies, TV shows, music, and stream them from a server that you own and you control, presumably behind your own firewall, and stream them anywhere. But the question that always comes up is, how do I access this stuff remotely? Well, in today's video, I'm going to show you how to do that using Tailscale. Jellyfin is the gold standard in free and open source media server software. So in other words, you can take movies, TV shows, music, audiobooks, DRM-free files that you own or at least are stored on your hardware in your house and stream them across the network to devices in your house, but also to devices anywhere in the world via Tailscale. So that's what we're going to do today. We're going to set up Jellyfin in a Docker container. I'm going to do this on top of Proxmox, which is a self-hosting kind of platform, if you want to think of it like that. Maybe you're new to self-hosting, and if you are, there is a video up here talking about how to install Proxmox. Now, today, I'm going to be running it on. There's a little HP Slim 290 back here, which I bought for $100 yesterday off of Facebook Marketplace. I know there's a lot going on in the world of hardware these days in terms of RAM pricing and hard drive pricing and what have you. And I wanted to see what I could buy for $100. And that HP Slim is what I got. 12 gigs of RAM, an i5 9500 CPU, and it's an entirely usable system. Again, in the current market, that feels like an unbelievable bargain, to be honest with you. Now, the reason I picked an Intel CPU, the i5 9500 in particular, number one, that's what it came with. But number two, Intel QuickSync is a really important part of this puzzle. Don't worry, we'll come on to the remote access piece in a moment, and there are chapters down below if you don't want to listen to me talk about Intel QuickSync for a couple of minutes. But essentially, when you take a video file, it is encoded in what's called a codec. So that takes basically the 24 frames per second video that you have and encodes it into a specific codec that may or may not be compatible with the device that you want to watch that content on. If it is compatible, great. You will do something called direct play, and the client will just play the file directly off your hard drive over the network via Jellyfin, and everybody's happy. There's no processing has to happen. But if your client device doesn't support the codec, we need to do something called real-time transcoding, and that is incredibly computationally expensive. Effectively, we're taking 24 frames per second of video and in real time converting that to a completely different resolution. And sometimes we also want to downmix the audio tracks from 7 channels of lossless down to stereo because we've only got 2 speakers in our listening space, for example. Or we're just on our phone on the bus and we don't care about the most fidelity, or we're trying to stream it over a small internet pipe like a 4G or a 5G connection on the train or in a coffee shop or at a hotel. Honestly, it's the most likely one that I find I end up using Jellyfin or any of these other media servers for remotely. So QuickSync is important because it offloads that computational stuff into hardware circuitry. It's incredibly efficient, number one. A CPU can suck down anywhere between 30 and 60 watts continuously whilst it's transcoding that video. Intel QuickSync can do the same thing, not only faster, but it does it because it's what's called an ASIC processor, a hardware, a bit like a crypto miner, honestly. It's like a piece of hardware circuitry that's designed to do one thing, and that's all it does. And the benefits of that are it's very efficient at doing it. And so instead of sucking down 30 to 60 watts to convert a video, QuickSync sucks down 3 or 4 watts. It's great. I have a website, by the way, quicksync.ktz.me, and this is basically a benchmark of all the different Intel CPUs that have ever existed. It's crowdsourced data. It's just a script you can run on your own server to see which is the most performant Intel QuickSync CPU for you. So if you see a one on the used market and you wonder where it stacks against the newer stuff that might have more expensive DDR5 memory and what have you, this website should help you. And in the end, that was what helped me make the decision to go with an Intel 9th Gen 9500 CPU in my media server. Okay, so that's the basics of hardware out the way. Use whatever you can get. I mean, really, Jellyfin doesn't need much in the way of hardware unless you're doing some transcoding, and then it does. But with Intel QuickSync, Anything 8th gen Intel or newer should be fine. So let's now talk about remote access. And why does everybody mention Jellyfin on the one hand and then Tailscale in the next breath for remote access? Well, the reason is, historically, the leading light in this space was a service called Plex. And Plex isn't really a media server. I mean, yeah, it is kind of, but Plex is really a series of services bundled together that happens to also serve media files. And one of the critical things that Plex offers is an authentication service. It's a cloud-hosted service that you log into to gain access to your local server. If that sounds crazy to you, it kind of is. But that's how Plex handles things like sharing your server with friends and family and punching through firewalls, although you just open a port with Plex and that's how it punches through the firewall. With Jellyfin, there's none of that. It's up to you to bring your own user and authentication mechanisms. It's up to you to bring your own remote discovery protocols and also to handle remote access. And the reason this is difficult, when you're in your house, you are behind the firewall. You're inside your safe zone. You can do anything. You can go anywhere on your home Wi-Fi, on your home network. So I can, from this laptop, ping my phone. You know, there's no barrier between them. We don't want that on the public internet, though. I don't want to be able to have everybody in the entire world reach my server without some kind of a firewall or a door or a fence, like some kind of ingress protection in the way. And that's what a firewall does. Now, this is born out of a problem that happened in, I guess, the 90s, probably the 90s or so, where we started to run out of IP addresses. And so a technology was born called network address translation. Essentially, this means that one public IP address can map to multiple private IP addresses on the inside of a private network. So when you go and type into whatsmyip.com, you will see your public ISP IP address. You won't see the 192.168 local address of your laptop, and that process is network address translation in action. It's fairly simple when you're doing outbound connections, so when your laptop wants to talk out to the public internet, but it gets a whole lot more complicated when you want to come in and allow things coming from the outside into your safe space, into your little world. Typically, you would do something called port forwarding. You would punch a hole in that firewall manually, and you would say, if, you know, let's use my mother as the example from England. If she wanted to access my Jellyfin server in the basement, I would need to say, when this connection comes in on this specific port, so my mother would enter a specific public IP address, she'd then enter a specific port, that would then hit my firewall, which would then go, well, am I allowed to let this through or not? Or am I going to go into full Gandalf mode and you shall not pass? Like, that's what happens in a firewall. That's its entire job. That packet then gets forwarded through the firewall to the internal device. So what you've just done is you've basically opened a hole to the entire public internet on that one specific IP address and port combination. Now, we all know in this day and age of AI that there are an increasing number of security vulnerabilities. Therefore, I cannot with a straight face say opening ports is a good idea. In fact, I haven't had a single port open in my personal infrastructure firewall now for many, many years. I encourage you to do the same. I know this is a Tailscale video, and that's kind of one of the reasons why I work here, is because I think this so elegantly solves the problem of remote access for people. With Tailscale, all you need to do is make sure that every client device that wants to connect into your Jellyfin server is on the Tailnet. So that would include, and this is where it gets a little bit complicated, but that would include the TV, maybe the Apple TV or the NVIDIA Shield or whatever you're using as your set-top box. It would include phones, iPads, laptops, what have you. You'd also need to make sure that Jellyfin is on the Tailnet, and we'll come on to how to deploy that in just a moment. But I wanted to take a moment just to explain why Tailscale is kind of mentioned in that same breath of remote access with Jellyfin, like all the time. The reason is it's the easiest way to connect your devices and services together. And Tailscale's free plan has 6 seats now. We updated the pricing a couple of months ago from 3 seats. It's now 6, so hopefully that will fit your family unit in it just fine. You've also now got unlimited personal devices. So this solution should scale with you and your needs forever. And Tailscale has been vocal in saying we are committed to keeping the free tier free forever. The best thing you can do to help Tailscale and our business model is tell your boss about it. If you're in a tech job and you are using remote access for anything, that's how Tailscale stays free. Our generous personal tier hopefully energizes folks to be excited about Tailscale and take it to work. All right, time for the meat and taters of today's video. Let's install Jellyfin. I'm hopefully going to assume that you have at some point here got a Linux box. I'm also going to assume you've got Docker installed on that Linux box. If you haven't, like I say, there is a video up here for you where I go through in excruciating detail how to install Proxmox and Docker and set up your first few self-hosting applications. I'll spare you those details today because I think that there's a point of diminishing returns of explaining the same thing over and over again. But in GitHub, there is a repo linked in the description down below with all of the files that you'll need for today's video. Essentially, though, all we need to do is copy a single Docker Compose YAML to our remote server. So look in the description for this folder right here, 2026-05 Jellyfin 01 sidecar. Now, a sidecar container is essentially its entire job is to connect the main Jellyfin container to your tailnet. That's literally all it does. And we configure a couple of things here in Docker Compose. You can dig into that if you want to. You don't need to know how it works. It just does. The only thing, though, that we need to specify here is an auth key. Now, an auth key is kind of like a password. This is how you log in the Jellyfin servers to your tailnet. So you can get one of those for free by heading over to tailscale.com and going to your admin console. Then click on the settings button up here in the top right. Click on keys. And we can generate a reusable auth key if we want to. I'm not going to. I'm just going to do a single use key. Copy that to my clipboard and put it straight into the file right here. That's it. We're done. Now we need to copy the entire contents of this file to our remote server. I'm going to do this in the browser with this. I'm just going to do vi.compose.yaml, press I to go into insert mode, copy and paste, and then I'm going to do an escape and then a :WQ to write and quit the file. Now you can use nano or whatever you want to edit this file. Now there's a few things I should probably point out before we actually save the file that we should go through. Let's just look in here real quick. You need to have these paths figured out on your side. There's nothing I can do to help you with that. You just need to know where your media is stored, and then Jellyfin will go and scan and index it later on. But I have my media stored under mnt/media, and then I map that to media inside the container, along with things like my app data. Now, app data is storing things like the library scans and thumbnails and all that kind of stuff that just, you know, Jellyfin is basically the database. It says this media file exists in this directory, and, you know, it's the mappings of things that are going on. It also contains the mappings to specific users of who's allowed to log in and who isn't. So this is the basics of Jellyfin itself. We have this now ready to go. And the reason I've done this on the Proxmox host, I know some of you are probably shouting at your screens going, do it in a container, do it in a virtual machine. The thing is, with Intel QuickSync and hardware accelerated transcoding, which is enabled in this image, by the way, is that you cannot reliably pass a QuickSync GPU, an iGPU, through to a virtual machine. You can kind of do it to an LXC container if you want to, but running Docker inside an LXC isn't the best idea anyway. It works, but I've had some teething issues, particularly around major Proxmox updates. So I've come to be at peace, and this is entirely personal preference, but I've come to be at peace with running Jellyfin on the host itself, on the Proxmox host itself, so that I get access to the hardware acceleration underneath. Now, to spin up Jellyfin from that compose file, all we need to do is a docker compose up/d, -d, I should say. This is going to pull down the latest Tailscale Docker image as well as the latest Jellyfin image from upstream. What will then happen behind the scenes is those containers will come up, they will start talking to Tailscale and say, hey, my name is this, here's my auth key, I want to have this host name on the tailnet, which, what do we configure that to? Host name of Jellyfin right here. And then once that's done, you should have Jellyfin on your tailnet. I should probably make sure that we have a couple of other things turned on as well. So under the DNS tab right here, scroll down to Enable Magic DNS, although I think it's enabled by default on all new tailnets since 2023 or so, late 23. So you probably don't need to do that, but you probably do need to make sure you've got HTTPS certificates turned on. And then also make sure that you've got a tailnet name that you like. So every tailnet by default comes with a name like this, tail6e5bf.ts.net. This is free and every tailnet gets one. But you can rename and you can re-roll the names of your tailnet if you want to something that has both a tail, Velociraptor, and scales. Have I just lost my tailnet name on camera? No. Oh, I can revert it, thank goodness. I've had this one for years and I really like it. I thought I just lost it. Oh, what's a relief. Okay, so something with a tail and something with scales, .ts.net. That's free and you can use that until the end of time. Okay, now Jellyfin, as you can see, has now appeared on my tailnet in the background whilst I was talking. I'm now going to copy this URL right here and I'm going to open it in an incognito window. That's because the first time you open the URL, we start reaching out to Let's Encrypt and start the whole process of generating you an HTTPS certificate. That process takes about 15 or 20 seconds. Chrome's timeout is always just a little bit less than that. So now the second time I go to this URL, make sure you add the HTTPS on the beginning, by the way, you can now see that Jellyfin loads with a TLS certificate, with no reverse proxy configuration. Okay, we kind of configured it in the Docker Compose file. That's what this whole configs bit at the top is. This is your reverse proxy configuration, effectively. And the beauty of all this is that it's only available to you on your tailnet. So let's go through the basics of setting up the server. Username, I'm going to Zaphod, whatever. Password, sure, fine. And this is where we would add a media library if we want to, go through and scan all of your content. That's not what this video is about. This video is about remote connections and sharing and all that kind of stuff. So I will spare you the details of setting up Jellyfin itself because there's a million other guides for that. All right, so we have Jellyfin now running on our tailnet. Every device that we want to access Jellyfin, we simply feed them this URL. So on an Apple TV or a NVIDIA Shield, or again on a phone or whatever, you would just feed it this URL. A couple of good clients I found lately on tvOS. There's one in test flight called Neptune. That's pretty sweet. It's still in test flight, like I say, but it has so much promise. It's far and away the best I've seen on tvOS. The other one on iOS that I really like, what's it called? Streamyfin. And this one's pretty sweet. I got it hooked up to my Plex right here, my Jellyfin, not my Plex. And it, you can do things like set the transcoding quality and select subtitles and languages. Some of those things sound like basics, but because Jellyfin is a fully open source ecosystem, it's not necessarily a given that all of those features exist on every single client. So it will take you a while to find the right selection of clients for your needs. On the NVIDIA Shield, so Android TV, I've been using Wolfin, WH, like dolphin, but with WH at the beginning. Anyway, this client, Wolfin's pretty good for NVIDIA Shields. But yeah, let's get back to the remote access now, okay? So let's say, hypothetically, we now want to share this node with a relative. The best way to do this, probably the easiest way to do this, is have them sign up for their own free Tailscale account and then go to this share option right here. You'll then copy the share link. You can make it reusable if you want to, and then send this to them through some instant messaging app somewhere. And then your Jellyfin server will appear in their tailnet. You have to use a fully qualified domain name, so you have to use, as a shared node, they have to use the jellyfin.velociraptor-noodlefish. Otherwise, they can't just type Jellyfin like you can on your tailnet. They have to use the fully qualified domain name. But that's it. You've just solved remote access for your Jellyfin server. Simply by sharing the node and sharing this link with this person, you've solved it. Now, there is another aspect to Jellyfin, which I haven't covered in this video, but I suppose I should. There's an app called Wizar, and you can use Wizar to invite people to your Jellyfin servers. Now, this isn't hooked up to the Jellyfin server we just created. This is hooked up to my own personal Jellyfin server. So what I would do is I would add this node to my tailnet in the same way we just did with a sidecar container. I then do new invite, and I can call this whatever I want. Create invitation, sure, allow downloads, whatever. And then copy this URL. And assuming that's a Tailscale URL that's shared out as a shared node to the other person, it just works the same way as Jellyfin does. So let me show you how this process actually works. I'm going to go through here and accept the invitation. You see, it's pretty slick, right? I'm going to select the invitation, and then I'm going to call myself Bob at example.com. Sure, create this, and away we go. And you can see that like this starts to show me all of my different bits and pieces that are in my Jellyfin server. You can see all my kids' TV shows right here. It gives the person you've just shared the server with a nice little wizard that goes through, tells them how to download the different Jellyfin clients, and then it takes them right to Jellyfin. Now, I know this is my personal Jellyfin and not the one we just set up in the video. You'll just have to imagine that Wizar is also configured as a sidecar. In fact, you know what I'll do? I'll create a second one. I'll create a second folder in here that's literally called Wizar. When this video is published, there will be Wizar with a sidecar container, and it will just work the same. So the only thing that you need to do as the administrator of this server is go into your admin console and share two nodes. You'll need to share the Jellyfin node and the Wizar node, and then everything will just work neatly together. And that really is how you solve Jellyfin remote connectivity using Tailscale. The beauty of it is that Tailscale establishes a direct connection between all of your nodes, so you get the best performance possible. If you're proxying it through a cloud VPS, and I have a video about how to do that with a cloud VPS up here, by the way, it's a bit more complicated because you have to proxy the traffic to the VPS. They have bandwidth limitations. You can do things with Cloudflare tunnels too, but streaming video is not allowed through their terms of service as far as I understand it. But the beauty of Tailscale is that all of the nodes connect directly to each other. There is no middleman. That tunnel is encrypted end to end, and the private keys never leave the devices in question. So Tailscale, even if we wanted to, we can't see what you're up to. Honestly, we don't care either. There has never been a better time to switch to Jellyfin. The plugin ecosystem is so unbelievably rich these days compared to even what it was just a year or two ago. So if you haven't given Jellyfin a look for a while, I strongly implore you to do so. I think you'll be happy, particularly if you are a Plex refugee. I think the writing's on the wall for that project, and Jellyfin is the future. The leaders of this project are committed to keeping Jellyfin free and open source forever. They have their heads screwed on. The project's headed in the right direction. So if you want a sustainable solution for your media that's going to last and stand the test of time, I can't think of anything better than Jellyfin. All right. Well, I hope you found something useful in today's video. And until next time, thank you so much for watching. I've been Alex from Tailscale.